Hello, today we'll tackle a small data science project using Chicago's crime data. The data is sourced from City of Chicago. With this data set, first, we will examine different features by creating different plots. Second, we'll create k-means clusters based on some of those features. Okay, let's take a look at the data. The data has about 1.2 million records across 21 columns. Here is a sample data set, date as index, identifiers, ID case numbers, primary type, IUCR, which is Illinois Uniform Crime Recording Code, same as primary type. Second is description of the crime, locational description, arrest, domestic, and area information, BIT, ward, and community area. BIT is the smallest police geographic area. Ward is Chicago's City Council district. Chicago has 77 community areas. So this is one of those 77 areas. And detailed XY coordinate latitude longitude, which we're going to use to create our geomap later on. From the date, we can extract year, month, day, hour, minute, weekday, which we're going to use to look at crime pattern and trends. Moving on to our EDA, let's look at by primary type. When we count by primary type, we can see theft is the most frequently occurring crime, followed by battery and criminal damage. When we count by location description, we can see crimes occurring on the street most oftentimes, followed by residence and apartment. Here I'm creating two different bar plots, arrest and no arrest. And when we group by primary type, we can see that narcotic-related crimes are leading to the arrest most oftentimes. On the other hand, no arrest, primary type, theft is the least arrested primary type of crime. And when we group by location description, as we saw before, crime occurrence is most frequent on the street. The same story, whether it's arrested or not arrested, most crimes occurring on the street. Moving on to creating a crime map. Here I pick several columns and look at 4 different crimes: theft, narcotic, weapons violation, and homicide. And look at their geographic distribution of crimes by using linear relationship plot across XY coordinate. Starting from theft, we saw across Chicago, pretty much all across Chicago, theft-related crimes happening. Narcotic, more scattered around, but still similar story as theft. Narcotic is happening across Chicago. When we look at weapons violation and homicide, it's more scattered, especially homicide is more concentrated in the west side and south side. Here I'm using Folium package to create a geomap. First, I group by community area. As I mentioned, Chicago has 77 community areas. I pick latitude, longitude, location description, and arrest. Create a new locational data set. And using Folium's circle marker to create these bubbles. Each bubble represents a community area. If I click on one of those bubbles, I can see The bubble contains community index information, arrest, locational description. So I'm just showing that it's possible to create cool looking map with Python. Okay, let's further explore the data with respect to datetime variables. First, by year, from 2015 to 2016, we saw the number of crimes increase a bit. From 16 to 18, the number of crimes was more or less stay the same. 2019, there's a cliff. That's because 2019 data is not fully populated yet. When we look at by year and month, sort of similar story. Across all these years, crime occurrence is higher during summer month, peaking July and August. When we look at by weekdays, we saw a number of crimes most frequently appearing on Friday and Saturday. When we look at cross interaction between weekdays and month, similar story. July and August, Sunday and Saturday are peaking in terms of number of crimes. By hour, crimes occurring more frequently during daytime, peaking around noon. We can further segment by hour and primary type to see primary type has a different occurrence pattern. The green line, which corresponding to theft, we saw is peaking around noon. That's same as here. So we saw crime occurrence are different by our block. So let's pick 2-hour block, see which crimes are appearing the most. So date hour 12, rank order by primary type. We can see that theft is the most frequently occurring crime, followed by deceptive practice. So this is not surprising because consistently theft is most occurring during noon, around noon hours, right? Crime committed around 3 a.m. Battery is the most frequently committed crime. Okay, let's move on to creating K-means clusters. So give you a little background, K-means cluster is one of the simplest and most popular unsupervised machine learning algorithm. A cluster refers to a collection of data points aggregated together because of certain similarities. As we saw before, the crime patterns are different by location, hour, among others. So let's pick those three data element: police beat, which is the smallest police geographic area, and hour, and IUCR. Again, this is a primary type. And we pre-process the data using label encoder, converting from object to numeric features. For demonstration purpose, I'm choosing 3 means. We ran this k-means. Runtime is fast, less than 10 seconds for 1.2 million records. And we analyzed the output. Silhouette score is about 54%. The silhouette measure how each object is closely matched to its own cluster. So it's saying about 54% of data points are closely matched within its own cluster. When we look at the distribution of these clusters, we can see 3 clusters are fairly evenly distributed. This is the final data set. We then visualize these clusters by creating 3D plots. Across XYZ, police beat, hour, and IUCR, we created these clusters, and we can clearly see that there are 3 different clusters across police beat, hour, and IUCR crime types. So in this project, we examined the Chicago crimes data, ran a popular unsupervised learning algorithm, K-means, to cluster based on features that we examined. Hopefully this was helpful, and hope to see you again. Thank you.